one of the things that frustrates me is how we as math teachers often rely so much on rules and procedures, because math is so much more than that. It's about discovery. It's about seeing patterns. It's about playing around with ideas and seeing what happens. That's where all those rules and procedures came from. Just people playing around and finding out what happened and then saying, okay, well, that works every time, so now we'll call it a rule. And if you just learn the rule without any of the why behind it, then you don't really own the knowledge. So division with fractions is a great example of that, because you've probably always been taught when you divide by a fraction, you multiply by its reciprocal, but maybe you never knew why that was. Don't get me wrong, we're still going to multiply by the reciprocal, but I want you to understand why. And so I'm going to start with a very simple looking division problem, 1/2 divided by 1/4. And the first thing I'm going to do is draw a picture of what that might look like. Okay? So here is a half. Right? We're going to start with a half. And then what we're going to do is we're going to divide it by 1/4, which means I've got this same circle, right? But now I'm going to divide it into fourths. So now I'm going to look at one of these fourths and say, how many of these things fits into the whole half? How many of these red sections fit into the green section? Well, it's 1, 2. 1, 2. 1/2 divided by 1/4 is equal to 2. Okay? That's what you want to picture in your head. All right? 1/2 divided by 1/4. How many fourths fit into a half? Okay. So that's an image. Now what we're going to do is we're going to relate it to multiplication. So, you all know, we've already talked about this, that 2 times 3 is equal to 6, right? And so we can do the inverse operation, which would be division, which would be to work this backwards, right? To take this and work it back this way. 6 divided by 3 is equal to 2, right? So if this is true, then this is true. 2 times 3 equals 6, so 6 divided by 3 equals 2, all right? We could state that algebraically as this. If A divided by B is equal to C, we've got 3 different numbers. If this is true, then I can work it backward and say C, right, divided by, nope, I'm sorry, I said that backwards. I should have said if A times B is equal to C, then C divided by B is equal to A, right? So we're working it backward. All right, so we're just going to hold on to this little nugget of information, all right? So division is just simply working multiplication backward. All right, so with that said, we're going to take that same problem that we already did, 1/2 divided by 1/4, and look at it through this sort of situation, okay? What we're looking at is this, right? We have C divided by B, and we want to find out what A is, right? We want to find the answer, okay? So if this is true, then there had to have been some number A up here. I'll write it right below it. There had to have been some number A up here that if I multiplied it by B, which in our problem is 1/4, the answer I got would have been C, which in this problem is the 1/2, right? So we're kind of working it backward. If 1/2 divided by 1/4 equals A, then A times 1/4 had to have been 1/2. So now we're going to look at our division problem kind of like a multiplication problem. So If you recall from our last video, we were working with equations that looked like this, where you have a fraction times your unknown variable. They didn't look like this though. They looked like this. Didn't we generally put the fraction in front and call it the coefficient? We did. It doesn't matter really where that number goes. It means the same thing. The coefficient is the number that's multiplied by the variable. So now what we're going to think about is, how did we solve this equation? We multiplied by the reciprocal of that coefficient. The reciprocal of the fourth is 4 over 1. Multiplying by 4 over 1 on both sides of the equation. Here's my equal sign. The 4's and the 1's cancel out, leaving us with a equals a half times 4 over 1 is, I'll do it this way, 4 over 2, if I multiply it this way and this way. And we can simplify that. 4 divided by 2 is equal to 2. So that was a really long way of getting there, but we're talking about the why, right? This is all about the why behind what we're about to learn. A is equal to 2. Isn't that the same thing we got up here when we drew our picture? It is. So now I'm going to go back and look at the same problem. It was 1/2 divided by 1/4. In every math class you probably ever had where you divided with fractions, the way you were taught was to take the reciprocal of the second number, whatever came after the division sign, and you multiply by that number. 1/4, the reciprocal is 4 over 1. This thing we just went through is the reason why we do it like that. All right? That gets us to the why. This is kind of that shortcut, right? You multiply by the reciprocal. 4 over 2 equals 2. All right, so let's apply that to a couple different situations. Let's say we have 2 divided by 3/7. So we have a whole number divided by a fraction. You're going to take the first number and then multiply it by the reciprocal of whatever comes after the division sign. 7/3. Now, when we're doing this multiplication, you might find it useful to put it over 1. If you don't, you just multiply that whole number times the numerator. If you like the 1 down there, so you remember to how to multiply, that's fine. 2 times 7 is 14. 1 times 3 is 3. 14/3. 2 divided by 3/7 is 14/3. That one would be a little difficult to draw out to solve, right? Let's try a couple more. 3/4 divided by 5/6. Pause it, try it. So we're going to keep going, leaving it as 3/4 to start, multiplying it by the reciprocal of this fraction, which is 6/5. And again, we can multiply straight across, then try to simplify. I'm going to go back to the way we learned in an earlier video, which would be to do some prime factorizations, just to do a little review of that. 3 and then 4 is 2 times 2 times, hopefully this comes back to you. 6 is 2 times 3. 5 is a prime number. 3 is a prime number, so we don't touch those. Right? This is how we simplify fractions in the multiplication process. Remember, this only works when we are multiplying. So what can we cancel? I see a 2 and a 2, and I think that's it, because we have to cancel numerators with denominators. What's left? 3 times 3 is 9. 2 times 5 is 10. 9/10. Let's look at one more. So let's say we have 5/8, and we're going to divide that by 15. We're going to divide 5/8 by 15. Now we have a fraction divided by a whole number. So we always leave this first fraction or first number alone, and then we're going to multiply it by the reciprocal of 15. What's the reciprocal of 15? Well, whole numbers can be written over 1, so the reciprocal would be 1 over 15. There we go. And now we do our multiplication. I always like to do my cancellation simplification during the multiplication process. So 5 over 8 could be thought of as 5 over 2 times 2 times 2. And 1/15 could be 1 over 3 times 5. Maybe you don't need to write all that out. Maybe you just can recognize what cancels. This way is always going to make sure you hit every number that's necessary. I see that 5s can cancel. Nothing else can cancel, so I put it all back together. We've got 1 on the top. Remember, when something cancels, there's still a 1 in its spot. 1 times 1 is 1. Across the bottom, 2 times 2 times 2 times 3 is 24. And that is not only division with fractions, but the why behind the reason that we multiply by the reciprocal. You might need to go back and watch this again. Maybe that was a little fast and you walk out, you leave this thinking, I don't know what just happened. Go back, stare at it, pause, look at it, re-listen. This might take you a few listens before you process every little thing about that. I'll come back and do it.